So when we're talking about analog, it's a continuous wave or a continuous signal that has non-stop information. So that's an important thing. So it's more true to reality because it's that continuous, it has the variation like real life has, that needs to be transmitted or stored. It can vary in frequency, which is how often, as well as amplitude or how tall. Like I've mentioned, if we're dealing with sound, amplitude affects loudness, and frequency affects pitch and tone. So those are some things that interference or distortions can affect. But analog recordings record more of what really happened in real life when that sound was made. So there's some pros and cons with that. When we're talking about digital, it's not continuous. It's broken into fragments or bursts of information that have on or off or set values. So each fragment of information has a specific assigned value. When we're dealing with computers, universally computers use binary, so it's either a 1 or a 0. Because the more variety you have in those values, the more opportunities distortions can affect those. But because something that was continuous gets converted into fragments or bursts or pieces of information, there has to be a code and an ability to interpret it. And that's why computers can help us interpret binary code and then turn it back into stuff that's useful for us. But if there is a code that has to be interpreted by someone or something, because it's pieces of information, then that means we're dealing with digital signals rather than analog signals. And we're going to look at a couple examples in these last few minutes that will hopefully clarify that idea of specifically our digital and what it means for me to have a code to interpret. All right, so I have a page from a book up on the overhead. Can anybody tell me what this book is about? What's the book about?
It's Harry Potter.
Okay, and why do you say it's Harry Potter?
Because I see the picture.
Okay, so you see an image, but can people put Harry Potter's image on other places? So can anybody tell me any of this to confirm what she thinks is Harry Potter? What do you think?
Also, I can read Chinese, so.
All right, so he knows some Chinese. Tell us what you can tell us about the Chinese on here.
I can kind of help her with the last two words of Nanhai, which means boy.
Okay.
Maybe that means something.
All right, so that could be because is Harry Potter the boy that Harry Potter is based around? So that could be the case. So we see some clues that might help us. Now, if you were fluent in Chinese and could read the whole page, would you be able to confirm if this page is about Harry Potter or not?
Mm-hmm.
Yeah. Is written language a code that we have to learn how to interpret? Yes. And if you haven't learned the code for Chinese, you can't interpret that code. Some of you might be able to help us with this page. If you know Spanish.
Oh yeah, it's Harry Potter.
All right, now some of you are seeing the Dursley. Names, are they basically the same no matter what language?
Yeah.
If it uses that basic alphabet versus the Chinese alphabet. But is the name Dursley only a Harry Potter name?
Well, it's the name of Dursley.
It is. So Maddie, can you tell us more of what this is saying, converted to English for us that don't know Spanish?
The first line says
The boy that survived. If you know Spanish or know the code of Spanish, like Maddie does, she can start interpreting that code and it becomes more meaningful to her, where most of us, this word might be meaningful, and if you've never read Harry Potter, then that's not even meaningful to you. But now, Is this a code you guys are more familiar with?
Yeah.
The code of the English language. It is the boy who lived, Mr. and Mrs. Dursley of number 4 Privet Drive. We're proud to say they were perfectly normal. Have you spent a lot of time in your life learning this code and how to interpret this code? Most of your education has been learning this code, right? Of our ABCs. So rather than just like the 1 or 0 like binary, we have 26 pieces to our code that we use to put together sounds, typical sounds humans make. We've converted that into a code. So same thing with that different stuff. Okay, guys, we're not quite finished. We're almost done, and then I'll let you guys put stuff away. But that's what I wanted to reinforce. The idea of digital signals, written languages, that go back thousands of years. Absolutely. Is it fragments of information that we take from what we hear, convert it to the code of our ABCs, and then we can read that code and say it out loud, convert it back to that analog sound? So that's just reading is taking analog stuff, converting it to digital. When we say it, turn it back into analog. So I want to show you one more example. Oh, 2 more examples. Morse code. Because the more variation there is, the more opportunities for distortions to mess things up. That went away. That's why Morse code just used the patterns of dots and dashes, kind of like the 1s and 0s for binary. So it can be more consistent. Back in the day, smoke signals. It's not just the physical barrier of the Great Wall that helped protect China, it was the communication system. They used smoke signals that only they knew the pattern of what puffs of smoke meant what, so they could easily communicate from across hundreds and thousands of miles in China to their generals, to the emperor, to be able to quickly communicate using digital signals, very old school, but digital, not electronic, but digital. And that was a huge, huge thing that helped the Chinese Empire be as strong as it was and defend themselves against very violent and aggressive attacks that was using digital signals. All right, so go ahead, put your stuff away, and hopefully that gives some clarity on just the basics of our analog and digital.